Hello students, how are you all? Welcome to the fifth part of the chapter Current Electricity. And in this part, we will mainly discuss about resistance. Resistance already we discussed in our previous part. Here we will see how this resistance depends on the properties of the wire or the conductor. I mean, what are the factors on which resistance of a conductor depends? It's a very important topic. We will see that if you choose different length of wire or different thickness of wire, then how the resistance will vary. First of all, I want to ask you a question. Say, let me draw it. This is the plug point. Fine. From this plug point, I am taking a bulb here. Fine. And say the power of this bulb is say 5 watt. It's a 5 watt bulb. Fine. Now, another plug is there. Now from this, I am connecting another bulb here. 5 watt. Okay. So this is also giving you light. This is also giving you light. And both the bulbs are connected with say 220 volt. Fine. You are giving potential difference, means equal potential difference to both the bulbs. Now what is the difference? The difference is just the length of the wire used by you. Here the length is very short. Here the length is too long. So do you think that the brightness of the bulb will be changed or the brightness of the bulb will remain same? What? Yes, the brightness of the bulb will differ. Obviously, here you will see that the brightness of this bulb will low, but here the brightness of the bulb will be higher. Why? Because less amount of current is, no, here higher amount of current is going, but here the amount of current which is reaching is less. Understood? Though both the bulbs are connected with same potential difference 220 volt, but you will see that in this case the amount of current reaching there is less, but here the amount of current is, yes, amount of current is more. Why? Because of the resistance of the conductor. Now we can say that the resistance depends on the length of the wire. Understood? What is the length of the wire? If you are taking, say you require 1 meter of wire, but instead of using 1 meter, you have used a wire of length 10 meter. Understood? So when you are using 10 meter length, so resistance will automatically increase because you are increasing the length. So resistance depends on length. So we can write that resistance is directly proportional to the length of the wire. Yes, I repeat, resistance is directly proportional to the length of the wire. Why? Because when you are increasing the length, the resistance also increases. As I told you, instead of using 1 meter wire, if you use a 10 meter wire, obviously the resistance will increase. Understood? So that's why we say that resistance is directly proportional to the length. So if you increase the length, resistance will also increase. If you decrease length, resistance will decrease. Understood? Now, one more question. Say, I'm using, this is the plug point, I'm using, here is a bulb, same 5 watt. Here is the plug, I'm using another wire. See, this is also 5 watt. This is also 5 watt bulb. This is also 5 watt bulb. Fine. Now, what is the difference between these two wires? Both the wires are of same length. Yes, length are same. But see, the first wire is thin and the second wire is thick. So, resistance of a wire also depends on the thickness of the wire. Yes. If you select a thicker wire, means you are reducing resistance. Yes. Resistance of a wire depends on the thickness of the wire. If you increase the thickness, if you take a thicker wire, then the resistance will be decreased. So, we can say that in both the wire, here the resistance is less, but here resistance is higher. So, resistance is inversely proportional to the area of the wire. Area means cross-sectional area. Now, what is cross-sectional area? Cross-sectional area means, say this is the wire I have taken. Fine, this is my wire. Now, what I am doing, I am taking a scissor and I am cutting it. Okay, so when you are cutting it, then this circular portion, can you see this circle? This circle, the area of this circle is called cross-sectional area. You understood? If I draw it, say this is my wire, fine, and I am cutting it. So, this area is called cross-sectional area. If area is bigger, means resistance is less. If area is small, resistance is high. So, resistance is inversely proportional to the cross-sectional area of the wire. So, we can write it like this. Resistance is inversely proportional. That's why we are writing 1 by A. And this means if you increase area, resistance will decrease. Understood? So, what we have seen? Number A. Resistance is directly proportional to the length of the wire. If you increase the length, resistance will also increase. And in number B, we saw that resistance is inversely proportional to the cross-sectional area. Means cross-sectional area, if you increase, resistance will decrease. Just opposite. Understood? One more thing on which resistance of a wire depends, that is temperature. If you increase the temperature of the wire, then resistance will also increase. So number C, resistance also depends on temperature. Understood? If you increase temperature, resistance will also increase. So these are the three things we have to remember. So this is a very important question for your exam, like what are the factors on which resistance of a conductor depends. Now if we elaborate the answer, first of all you have to write number A, resistance depends on length. How? If you increase length, resistance will also increase. So we can say that resistance is directly proportional to the length of the conductor. Number B, resistance is inversely proportional to the cross-sectional area. Cross-sectional area, you understood? This is the cross-sectional area, the thickness of the wire. Okay? So resistance is inversely proportional to the thickness of the cross-sectional area. And number C, resistance also depends on temperature of the conductor. If you increase the temperature of the conductor, resistance will also increase. Understood? So, what we came to know? We know that resistance is directly proportional to the length of the conductor and resistance is inversely proportional to the cross-sectional area of the conductor. Let us write that. Resistance is directly proportional to the length and resistance is inversely proportional to the area. Fine. Now we'll combine both the equations. Okay. If you combine them, what we get? R proportional L by A. Yes, by combining these two equations, we are getting R proportional L by A. Fine. Now, if you convert this proportional sign into equal sign, one constant will come. L by A. Fine. So K is my constant, but here I am not going to use K. I will use a special symbol. Yeah, for this constant I will use a special symbol. This symbol is this. Now what is this symbol? This symbol is called rho. This is rho, R-H-O, rho. Understood? And the name of this constant is resistivity or specific resistance. Yes, it has got two names, specific resistance or resistivity. Understood? Now, if you cross multiply it, what we are getting? Rho L equal to RA. Fine. So, rho equal to RA by L. Okay. Now, we know what is rho. So, rho is specific resistance or resistivity. Fine. So, if I ask you, how will you calculate specific resistance or resistivity? Then specific resistance and resistivity, to calculate it, we will write rho equal to RA by L. This is the equation. So here two equations you have to remember. First of all, R equal to rho L by A, this equation and this equation. Both the equations you have to remember. Actually both the equations are same. Just we have cross multiplied it and we got rho. Both the equations are same. So R equal to rho L by A. It's a very important equation. This is also required in numerical, which we'll be seeing after discussion of all these things. Fine. Now, if I ask you, what is the definition of this specific resistance? Fine. Now we'll see how to find the definition and unit of specific resistance. Let's see. Here is this equation. To find the definition and unit, we'll use this equation. Let's see. Rho equal to RA by L. Fine. Now, I'll be taking a wire. A simple wire I'll take whose length is 1 meter and area is 1 meter square. Fine. What I'm doing, I'm taking a wire whose length is 1 meter and area is 1 meter square. Now let us put these values here. So rho equal to R. Area is 1 by length is 1. So 1 is cancelled. So rho equal to R. So from this equation, we will see what is the definition of specific resistance. See how. We'll write in this way. Specific resistance is the resistance. Understood? Specific resistance is the resistance of a wire whose length is 1 meter and area is 1 meter square. Understood? I repeat. Specific resistance is the resistance of a wire whose length is 1 meter, area is 1 meter square. But instead of using meter, we will use unit, U-N-I-T, and this is unit square. Fine. So, how can we say the definition of specific resistance? Specific resistance is the resistance of a wire whose length is 1 unit and area is, cross-sectional area is 1 square unit. Understood? Now we will see how to find the unit of specific resistance. To find the unit of specific resistance, we'll use the same equation. Rho equal to RA by L. Fine. We will take the same wire whose length is 1 meter and area is 1 meter square. So length is 1 meter and area is 1 meter square. Understood? Let us put the value. Now, what is the unit of resistance? Ohm. We know that, we already discussed in the previous parts of this video. It's ohm. What is the unit of area? Unit of area is meter square. So we'll write meter square. What is the unit of length? Meter. Meter. See, meter. So now if you cut meter square by meter like this, you are getting ohm meter. So ohm meter is the unit of specific resistance. Understood? Now instead of using meter, if you use centimeter, like length is 1 centimeter, area is 1 centimeter square, then how will you describe the unit? Instead of using meter, just will write area of centimeter square. Centimeter square. What is the unit of length? Centimeter. So just write centimeter. So same way, cut centimeter and centimeter square. You are getting centimeter. So ohm centimeter is the another unit. Understood? So we are getting two units. One is ohm meter, another unit is ohm centimeter. It's very simple. So we saw specific resistance or resistivity. As I told you, rho has two names. What are those names? Specific resistance and resistivity. So what is specific resistance or resistivity? Specific resistance or resistivity is the resistance of a wire whose length is 1 unit and area is 1 square unit. Finished? And what are the unit of specific resistance? Ohm meter or ohm centimeter. Fine. Now one more information for you. As I told you in the beginning of this video, that you are taking a wire of length 1 meter. Fine. Say you are taking a wire of length 1 meter of copper. Yeah, it's a copper wire you have taken. I am also taking a copper wire, but the length of my wire is 10 meter. You understood my question? You have selected a wire of length 1 meter. I have selected a wire of length 10 meter. But both are copper wire. Since both are copper wire, so their specific resistance will be same. Because I am also using copper wire, you are also using copper wire. Since both the wires are made up of copper, means materials are same, so the specific resistance will be same. Because I told you, rho is constant, it does not change. It only depends on material. What material your wire is made up of. Understood? By what material your wire is made up of, rho depends on that. So if all the wires you are selecting, if they are made up of copper, then all the wires specific resistance is same, but their resistance will be different. How? Yeah, because they are of different length. Understood? So the wire which you have selected 1 meter, the wire which I have selected 10 meter. Since length are different, so resistance will be different. Understood? Now since both the wires are made up of copper, I mean same material, so their specific resistance will be same. Understood? So resistance depends on the length and thickness of the wire. I mean resistance depends on the length and cross-sectional area of the wire. But rho, specific resistance, does not depend on the length or area. That only depends on the material by which your wire is made up of. Understood? If your wire is made up of copper, even my wire is also made up of copper, then both the wire has same specific resistance, because specific resistance is constant. Understood? Now let us discuss some numericals based on resistance and specific resistance. First numerical you can see displaying on your screen. The resistance of a wire is 5 ohm. If its length is doubled, how its resistance will be changed? Fine. Here a particular wire is given. Say this is the wire which is given. Fine. In this wire the length is not given, but they are saying that you are changing the length in double. Understood? Say its length is L. What is the length? L. Now, if you are increasing the length double, so what will be the new length? 2L. So let us write it. So, two cases are there. This is the first case and this is the second case. In first case, let length be L. So as I told you, as it is given in the question, length is doubled. So what will be the length? 2L. Fine. Now, just think about a rubber. Yeah, just think of a rubber band. Now, first of all, when you are taking the rubber band, you can see the thickness of this rubber band. Now, if you increase the length of this, I mean, if you pull the rubber band from both the sides, you will notice that when you are pulling it, its length is increased, but its thickness is decreasing. Understood? I repeat, simple rubber band you have taken, that rubber band, say this is the rubber band. Now, if I pull it from both the sides, that means I am increasing the length. But if you see, you will notice that the thickness of the rubber band will decrease. Yes. So same way, this is the wire which is given to me and I am increasing its length, means its thickness will be decreased. So if you increase the length twice, then its area will be half. Understood? So when you are increasing the length twice, I mean 2L, then its area will be A by 2. Understood? Its area will be A by 2. If you increase the length thrice, like 3L, then its area will be A by 3. A by 3. Understood? In this way. So we are not discussing this. Length is 2L, then area will be A by 2. Fine. Now let us use that equation R equal to rho L by A, which we discussed before this. So what is the resistance? R equal to rho L by A. Fine. Now in the first case, what is the resistance of the wire given? 5 ohm. So 5 equal to rho L by A. Understood? Now let us see this. Its resistance equal to rho L by A. Now this is R equal to rho. What is the length here? 12. So my length is 12. What is my area? A by 2. Put it A by 2. So R equal to, this one will get reciprocal. So it will be rho 2L2 by A. Yeah, just A by 2 is getting reciprocal. So it will be 2 by A. So R equal to 2 to the 4 rho L by A. Understood? So R equal to 4. Now what is rho L by A? Rho L by A means 5. Understood? So let us this equation number 1. So rho L by A means 5. So instead of rho L by A, I will write 5 into 5 equal to 20 ohm. Got it? So when you are making the length double, the resistance will be 4 times. I mean it was 5 ohm, now it is 20 ohm. Understood? Let us see another numerical. Next numerical. Resistance of a wire is 8 ohm. Fine. Now the wire is doubled on it. Doubled on it means this is the wire you are cutting exactly from middle. Understood? This is the wire exactly from middle you are cutting, and this portion you are joining here. That means like this is the wire. Fine. I am cutting from middle. Okay, and this portion I am joining here. Understood? So this portion I am taking here. So now see, if its length is 10 meter, now what is this length? Yes, 5 meter. Obviously length is reducing. First length was 10 meter, now length is 5 meter because I am cutting from its middle. And its area, say first its area was 5. Now again another 5 because this is 5. Now this is also coming. So area is 5, 5, 10. So area is becoming double, but length is halved. Fine. So a wire is doubled on it. That means length is getting half, whereas its cross-sectional area is getting doubled. Understood? So this is the meaning of that word, a wire is doubled on it. So let us see. Again, this is the first case and this is the second case. In first case, length equal to L. In the second case, length is getting half. So L by 2. Fine. In first case, area is A. Then area is getting double. So that is 2A. Fine. So first case, length is L. Second case, length is getting half. And area is getting double. First it was 5, now it is 10. So area is getting double. Fine. Now let us use the same formula. R equal to rho L by A. R equal to rho L by A. Fine. What is the resistance of this wire? It's given in the question. What is that? 8 ohm. So we are writing 8 rho L by A. Here resistance equal to rho L by A. Rho L. What is L? L by 2. L by 2. What is area? Area is 2A. 2A. Correct? So R equal to 2 to the 4. So that is 1 by 4. Rho L by A. Understood this simple calculation? 2 to the 4. 1 by 4. Rho L by A. So R equal to 1 by 4 into rho L by A means equation 1. Rho L by A means 8. So instead of rho L by A, write 8. So 4 to the. So 2 ohm is the resistance of the new wire. Understood? So when your wire is doubled on it, then resistance will be 2 ohm, whose resistance was 8 ohm before. Understood the sums? You must practice this sum. These sums are very important for your examination. Thank you.